basically, these days, the trends are really changing when I talk of structural engineering. So I understand most of you are into structural engineering, which is the analysis and design part. So I would say, with the given time now, these definitions of what a structural engineer is supposed to do are changing a lot. We are not just a structural engineer is not just confined to doing the load calculations, analysis, and designing the reinforcement and member sections and all. So the scope has really increased in today's world when we're talking. So of course, so many interdisciplinary things are coming up, and the way infrastructure has become so advanced, techniques have become so advanced. So structural engineer also has to keep up to this. So, but of course, we have to understand that structural engineering is something, which is a very old art. It is one of the basic engineering, I would say. Civil engineering is a very basic engineering. So humankind, as we know from ancient times, they have to build their homes and everything. So this art has been known to very ancient civilizations also, and we see these structures, which are all testament of the kind of skill a structural engineer has been having, and they're still standing today. We are talking of so many 2000 BC, we are talking of these structures, and they're still there. So this is nothing but structural engineering. So great buildings, still we see Sanchi Stupa, the Athens building, 2500-year old, Taj Mahal, 350 years old, then Eiffel Tower. All these are just I would say marvels that speak of what great profession the structural engineering is. So what kind of accomplishments we have been achieving, and in today's world also we can see how structures are coming up. We see houses, bridges, flyovers, high rise buildings, spacious shopping malls coming around us, and they're all structural engineering marvels. There's so much going into it. These I've specifically included these pictures to show how bridges, how they add to the beauty of the city, apart from their basic function of carrying the traffic over a obstruction of a road or a water body. So definitely a structural engineer has to think on those lines. You can create a very simple building, a simple bridge which looks like a regular bread and butter, or you can create something, a marvel like this, which can actually can be will be talked about, and in fact it can become a tourist spot also, and government can have some revenue generation also from these kind of things. So these kind of concepts are also coming up. So structural engineer has to think about, creativity is always there, of course, but we have to start bringing it out in terms of aesthetics also. So, of course, engineers, we are creators of artifacts. Original thinking has to be there, but again, the constraints are put. You have to have affordability, economy, and practicability is another very important aspects, which we have to tell all the structural engineers that whatever you design, it should be practically possible to construct it on the site. Okay, so now the modes are changing. We have to also understand about financing, project management, information technology. We see so many smart things coming around us. That is all IT, which is getting involved into the buildings, the structures. So, as structural engineer, we cannot say that we don't want to get involved in this thing. So, these are part and parcel of a structural engineer now. Okay, so there is so many interaction these days. People talk of holistic design and everything. Everything has to start. All the team members must be involved right from the start. So there is full ongoing interaction, which has its a lot of advantages why this thing has picked up so much. So a structural engineer also has to maintain effective communication also, across professional boundaries. So this is also required from a modern structural engineer. So an innovator, we have to design all these buildings, which we of course understand, which we know from basic, when we talk of structure fit for loads, a structure fit for economy, for durability, safe. Okay, and of course another very important aspect what you see on the fourth point is buildable without inconveniencing the community. This is another part which has picked up a lot. When the structure is being built, the way the construction site is set up, so all those kind of things, they have to be seen that the community doesn't get too much discomforted because of it. And aesthetic, of course, I've already paid enough stress. So of course, as design engineer, we have this dilemma that there is no correct single solution to a design problem. There are many possible correct solutions. Okay, so of course, what comes in then is the subjective, design, which is selected, individual taste. Okay, solutions may be for specific requirements. So, say same solution may not be applicable for everywhere. Okay, and a designer has his own, his or her own bias, or their kind of subjective, what kind of experience they have, what kind of thinking they have. So design problems actually are open ended, so there are many possible solutions to that. So we have to, of course, within the constraints that we all know, cost, time, safety, and all those things, we have to come up with a design, an optimum solution, basically. That is what is required. And that is where, these days, how artificial intelligence is also coming up in structural engineering now for optimization and all these kind of things. So, we are not basically in isolation. There are any technology you talk of, it is now applicable for structural engineering also. Okay, so of course, this is a great profession. These are just words of a former president of United States. Won't go into a lot of details, but the idea is, what we civil engineers, what we built, what we design, that is standing in front of the entire community for the next 60, 70 years to see. So it has to be a good work. We cannot hide our things under, stitches, or we can't hide our things under other things like other professions. So civil engineering which is something which is there in the open, and we should be, very proud to show that yes, this is what we have done. We cannot hide our work anywhere. It will be there. And plus we have this onus that people are using these structures. So safety of people, safety of property is another onus. And I think latest incidents that has happened in Gujarat, the collapse of the Mobi Bridge, that has actually shaken everyone. That is a very classic example of, how response, what kind of big responsibility civil engineers have on them. So definitely I'll be sharing one article on that also with all of you. So that, that is a very classic example of how civil engineering, a structural engineer's role, apart from not only it stops at design, how everything has to be seen, how the structures maintenance and everything has to be done nicely. Okay, so structural design, of course, as we said, it is a process. We have to select proper materials, which is again another aspect where a lot of things can be done by a structural engineer these days. A lot of things are expected from a structural engineer. Choosing the proper material. Okay, then is the proportioning of the elements, and definitely it's an art, engineering, science, it's a technology. Okay, so that's what we are using. Okay, so when I do structural analysis first, so what I do is I determine the effects of loads on the physical structure and the components, like the deformations, the internal forces, the stresses, the support reactions, accelerations, stability. Okay, so basically the key part of engineering design of structures is the results. They are used to verify that a structure is fit for use. Okay, so the idea is analysis helps us in doing some physical tests, which can be otherwise time consuming and very costly also. So that's how analysis helps us. Simulations, that's what we talk of. And these days, these are becoming very common. And I'll also share this as one of the recent trends also, what, structural engineers around the globe, what they have started doing. Okay, so we are using applied mechanics, when we are doing all the analysis of forces, stresses, and everything. We are using material sciences, how materials are behaving, how concrete is behaving, how steel is behaving, any composite construction that we are doing. New materials are coming in the market these days, so all those things, they are all related to material science, and applied mathematics is there. When I'm doing a structural analysis, I'm doing so many matrix operations, finite element, when I'm doing so many differential equations we are solving, when we are going for dynamic analysis and these kind of things. So definitely there's so much of art and technology and engineering involved for a structural engineer there. Okay, so definitely, design, as I said, is open-end, but analysis, we know all the parameters, and there is a unique solution, of course. So these are the two differences since we are talking of analysis and design. So I just thought of just putting a few words on that. Okay, so of course, we have to have time limitation, cost, environmental constraints are there, the purpose, the building has to be fit for the purpose for which it is being built. Okay, so another very essential objectives which have now started coming up in recent times are the health, safety, and welfare of the occupants. Especially COVID times have taught us, how hygiene is to be maintained, how we have to keep everything clean and neat around us. And since buildings are being used for so many purposes by so many people, and if I talk of an office or a colleges, we are spending almost 8 to 9 hours every day here. So health, safety, and welfare of occupants have become one of the core area which is of concern for a building, and structural engineer has to get involved in this aspect also. So they have to play the role in this. Then of course initial cost minimization is there, and another aspect which has picked up is the life cycle cost. Okay, so one is the initial cost and one is the life cycle cost. Throughout its life, what kind of costs will come for this? So people have started looking into these aspects also, given the kind of changes in environment that have come with the excessive use, the way humankind has has been tapping into the earth's resources. So we are falling short of resources now. So now everything we have to look what material we are choosing, what kind of techniques we are choosing. So what is their impact on the environment? We have to start questioning everything on that aspect. Okay, so I have to, of course, understand that I have to look for the best alternatives solution if possible, optimized, which has all these things. Okay, so of course, constraints are there for a designer. Sometimes the constraint is there: the beam cannot go deeper than 200 mm. So we have to go for such these kind of design solutions to look into that. Then there are standards which are value or range of values associated with each constraint. Like our standards, IS standards. There are BIS standards. Then there are British standards, New Zealand standards, Euro standards. So basically, the most of things they are governed by that. So the idea is to have some standard around which the structures are built, so that these things can be regulated, and there is some standard which is maintained. Okay, so code specifications are of course helping us. They are the detailed set of rules, suggestions. So as a structural engineer, we should have due knowledge of all these codes. We should know, how to use them, which are the applicable clauses for us. So that's a very important part. If I'm missing on a major load because I didn't look into the code and use it, so that is again a big, I would say a big, I would say. I haven't looked into it, so this is an on-site. This is I have overlooked something which is very important, and the structure is not safe there. So definitely codes they are formed after by experts after a lot of research, a lot of adopted after seeing a lot of things. Research goes into it, and of course from how buildings or structures have been performing in the past. So that's how they do, and these codes get revised regularly. So another very important aspect for structural engineers to keep him or herself updated with the latest things which are happening in the codes. If some new revision has come, so we must be apprised of that and ready to use it. Okay, like recently in few years, these codes for the loads IS 875 1893 were changed. They were revised. NBC was revised, and very soon we are expecting a revision in IS 456 also, the code for RCC. So that's also has been long due. I think very soon it is expected to happen. Okay. So basically, we have to make it buildable, and all those things are there. Okay. So multidisciplinary task, if you all, I think, have been able to appreciate till now, there is planning, there is analysis, design, and the way it has to be constructed. So when construction happens, structural engineer is always involved there also. Okay, so we are constantly, the structure when it comes up, it is involving civil, electrical, instrumentation, mechanical, architects, green consultants, regulatory bodies. So many people are involved, stakeholders, and everyone has to go hand in hand. So just starting with few structural systems. So when I'm talking, since I'm talking of structures, so there are so many structural systems which are available, and which gives us variety to come up with such fantastic structures, the marvels. So definitely the knowledge of these structural systems is very important, and many of these keep on updating also. We see high rise buildings, new type of buildings. We see signature buildings coming up, like signature bridge in Delhi is one example, or how they executed. We have such beautiful bridges around us, new ones coming, some have come just around. So new structural systems also keep coming up. So that is all, of course, knowledge of basics is there, and of course how much creativity we can put into that. Okay. So we have to see, the feasibility, the functionality, the technology, and as I said, sustainability is the word. Okay, That's the need of the time, since our environment has been polluted too much by the humans. So we have to keep in mind now, whatever we build, what effect will it have on the environment. So our effect should be minimum on the environment. Okay, then innovation of course has always its plus point. To have innovation in any structure, as I said, it can help in saving a lot of material also. Some technique, new technique comes up, and plus maybe with innovation, a good structure, it can become a revenue generation also. Okay. So a multi-discipline project organization these days, what we are talking of are the AEC, which is the new term, which has picked up, which is the buzzword, especially, in Western countries. So they're not talking of any single person who's a structural engineer. So they're talking of an entire AEC company, which is architect, engineer, and contractor. So basically, the idea is to have the entire end-to-end solution from one person, so that there is minimum, disparity or communication gap or anything, so that all aspects are looked at the same time. So we'll have more look at that also. So if I see, basically, project manager, if he's there, he has under him the design team, then there are owners representative, engineer, architect, civil engineer, mechanical, then under civil also the geotech, survey, space, urban. So all these things, aspects are very have become very important for projects now. And when structural engineer is designing these things, he needs to know all the aspects related to all these parameters. So everyone will be involved. That's how it's a multidiscipline project now. Okay. So of course, the overall design process involves a lot of steps. We do primary design. We look at all the alternatives, which is the best one that is worked out. It is not just one go that we go with. So we have to accordingly do modifications and everything until a final design is done. Okay. So a structural design process, when I'm talking of invention or modification of structural system, okay, so what required here is knowledge, experience, imagination, intuition, and creativity of the structural designer. When I'm doing preliminary analysis, so I should have a good hang on what is to be approximated, how it is to be approximated, the loads, the behavior. Then proportioning members and joints, so knowledge of design criteria, knowledge of design codes is required. When I'm doing analysis, so proper loads, how the particular member will behave under this load, this kind of behavior, this knowledge is important. Then evaluation, design criteria, design codes, they become very important. So as we see, definitely in-depth knowledge of the subject is required when we are going for the design, apart from the other things that have come up. Okay. So we design for strength, we design for serviceability. It's very important, the structure should be serviceable also. If people are not comfortable using the structure, so it defeats all the purpose. There are deflections, it may not collapse, but there are high deflections and people are not comfortable sitting under that beam. Or you're going on a bridge, you're riding on a bridge, there is this expansion joint sound coming again and again as you cross the span, so that becomes a little discomfort for the riders. So all these things should be kept in mind, when we are designing the um, structures. I won't go into details, of course, you're all teachers. So this is what I was talking of, durability and life cycle cost. This has become very important now, that structures should be made more durable, so that there is minimum, material, minimum money being put into the repairs, retrofittings. So it should be a durable structure. The life cycle cost is looked into, that what will be the life cycle cost, not just the initial cost. What we used to see is, okay, at minimum cost you have to put up the structure, that is the economy of the structure. But also, over the entire life, what kind of repairs and all will come up, what kind of maintenance will come up in that, how much material will go into it, what cost will come. So that is what is important these days. So life cycle cost analysis, LCA, life cycle, LCCA, that is another very important aspect which every structural engineer now must know, so that when they start the design, the kind of materials they choose, the kind of structural system they choose, that should incorporate these things, because structural design is kind of the first step when a structure starts coming to life. So these things have to be looked into, very important. Okay. So we have, of course, so much infrastructure to provide because of our population which is growing, and so much industrialization is coming around. So there's lots of infrastructure which is coming up, and definitely the infrastructure that now comes up should not harm the environment. That is the whole idea. So we have to provide housing. Then there is land contamination issue is happening, water pollution, environmental degradation, climate change, ozone depletion, deforestation, acid rains. We are all feeling all these things. The way climate is changing, the weathers have now kind of changed, not what it used to be earlier. The sardi garmi has become very different now. They are coming at different times. So all this, what structural, I would say structural engineering has been doing all the designs and all. So the infrastructure is a big part of all these changes. So definitely structural engineer has a big role to play. Okay. So we have to understand that there are old buildings which have been around for a long time now. They are asking for repair and maintenance. So there are durability considerations. Their budget has to be allocated. So it is costing the economy quite a bit. So definitely this is another thing. So we have to understand that infrastructure, there is new to come up, there is old that requires attention. So there is a balance to be seen, and we have to understand that the new structure at least should be done in a right way. Okay. So time is very important. Time wasted is money wasted and opportunities lost. Okay. So definitely design should be done in a way that it is easily operational on the site. Okay. So delays, anything that happens, that is basically we are losing on money and opportunity. So these days nobody likes that. So owners, the contractors, as I'm saying, it's these days the trend is a full package that is called the AEC, architect, engineer, contractor. The same firm they are doing. So they called it AEC consultants, AEC companies. So the idea is to have an end-to-end solution, and all these things should be coordinated well. The design, the construction part, and the planning part, they have to be coordinated well. Okay. And now, another thing that is coming up now is to have alternate materials so that we can have cost competitiveness in our structures. So, especially India, we are a concrete loving nation. Okay. So, we have to start understanding that how we can bring in more alternative materials in concrete itself. I will share in some time. How concrete has grown immensely with the new kind of interventions that have come with concrete. So what kind of options are available? So it is we have to structural engineer is the person who has to bring in that material to the structure. Okay. So we have to look for the best optimal solution, how we can bring down the cost. These days there are so many materials which are available. So definitely, and steel is another very good material which is recyclable. It is a sustainable material, it is a green material because it can be recycled and used again and again. And of course, use of steel is related to the GNP also, the growth of economy of a country. So that has to be there. Okay. So there are various for life cycle cost. There are various codes which are available. IS 14,000, 17,000 series are also there. ISO, and there are various these days even online portals are available which are helping you do life cycle cost analysis. So whenever you're picking up a material as a structural, you just see that you have a look into its NCA, that what impact will this material have before you choose it. Okay. So of course, as I said, there is a cost also involved, not only in building it, in maintaining it, but also in dismantling the structure. The cost is involved, and then whatever is the salvage value that we get out of it, this total number becomes the life cycle. So we have to look into the entire aspect these days. Okay. So initial cost, of course, there are so many things we know as we go, as it goes into construction and everything, design and everything. Okay. So just showing few pictures that I mentioned earlier. When we build a structure, the community should not be inconvenienced. So that is something that has now again started picking up, but of course that needs a lot of attention in India still. But other places, this is taken very seriously. It's not that some flyover is building up, coming up. So the for many years now, the traffic is diverted. People are getting delayed for their office and everything. Commute time has increased, so these things should not happen. We have to arrange ourselves on the site. So with proper planning, with proper coordination among all the involved parties, like engineers, as I said, various engineers and everything, contractors and everything, this kind of things can be planned beforehand, so that this happens in a timely fashion, in minimum time and minimum disbursement on the road. That's what we're looking for. Okay, so all these kind of things now, these are not liked by people anymore. So we have to look into this aspect, and structural engineer will be a part of this kind of planning to understand that this thing should not happen. Okay, so we have to understand, like, if we are not inconveniencing the society. Okay, so sharing just some pictures which one of a friend from Instagram had shared once. Okay, so periodic maintenance cost is also, of course, there. Okay, so this is something I think which is a neglected activity in India. So many examples for what has happened because maintenance was not done properly. So that is also very, very important. Everything requires maintenance, whatever is functioning. So structures also, they need to be maintained properly. Okay, so we have to look into the proper maintenance. They need due whatever repair or rehabilitation is required, that has to be done. So we have to understand, okay, that concrete cannot last forever without maintenance. It requires maintenance. Okay, and it's not that concrete bridges outlast steel bridges. In fact, we would say that if you look in India itself, there are many old bridges which were built in British time, which were steel bridges, and they are still working quite nicely as compared to some modern concrete bridges that were made. So we have to understand, what type of material we choose for what kind of solution. It's not that concrete is not good or steel is very good, but we have to see what is our requirement and how best we can, come up with the solution using the best material at the place. Okay, so all these things, they have to be looked into, of course. Okay, and all these aspects are also there for life cycle cost. So a structural engineer has to look into all these aspects. So everyday life of a structural engineer is doing all these design structural systems, how to assemble the components, then what kind of design requirements are there. So this is how a structural engineer goes around, apart from the things. Okay, generally, as a structural engineer, what we should be careful is, many times the mistakes that really happen are because there is lack of conceptual clarity on what has to be done. Lack in visualization. We need to visualize, okay, what I'm doing at last, how the structure will look. Okay, many times you're doing incorrect modeling as per the specific software. Then many times there is lack in design concept. Okay, and we have to understand that ultimately it is the design drawing which is our language. How we'll communicate. Nobody will be looking at the design calculation thick notebooks. When structure has to build on the site, what will go is the drawing. So drawing is something that a structural engineer has to put a lot of attention, because that is his design communication to the outside world. Okay, so when I'm talking of conceptual clarity, what we mean is that we should know what type of structure is coming up, what kind of material should go into it, RCC, steel, composite, or any other alternate material. Okay, then what kind of grades or their particular properties of the material that we pick up. Okay, soil investigation should be available. That is very important. A structural design cannot happen without it. Foundations, we start from foundations, and this is the first thing which has to be there. So don't start a design until you have this kind of data. Okay, which code is to be followed? That's very important to understand which code is to be followed, and then identifying all the correct loads which are applicable for the particular design. So these are very important things. We have to be very clear about our concept of what is to be designed. Okay, then deciding the method of analysis, what kind of analysis method we want to go. These days we are going into or more advanced also, which I'll show you in some time, the performance based design, going above and beyond the limit state design. Now, India is also moving towards that. And then type of cladding, the construction aspects, we have to have ground clearances. What will be the method of construction or erection, the sequence, that will matter a lot, because say I haven't taken into consideration that the final, say I'm designing a bridge which will be six spans or something, And I haven't considered that there will be, in the meantime, there will be such because of construction sequence, there will be a time when the full gravity load will not be mobilized, and there will be other kind of cantilever loads and all coming up due to partial construction stages, and the structure might fail at that point. So I have to look into all this. So I cannot just keep my eyes numb that how construction will happen. I have to have knowledge of that. Excuse me. Then visualization, entire geometry is finalized, including stair, lift, opening, offsets, types of connections, critical load conditions, what will be the deformation shapes, type of foundation, especially underground structure, machine foundation, space structures. I have to take care of all these things. I have to visualize, how they will come up on the ground. So accordingly, they have to be designed. Okay. Then in analysis, what kind of software I want to pick up. Okay. What kind of support conditions, actual construction, what are the conditions. So I have to, do the best estimate when I'm doing it, the analysis. Okay. So all these kind of things we have to put into things. Okay. So definitely understanding the software itself, say stat, there are many concepts. So these days there are so many softwares, midas and everything. So every software of course has a basis. The basics are still the same. Whatever the software may call it, the basics are still the same. A bending moment is still a bending moment. A torsional moment is still a torsional moment. So those things haven't changed. So we should try to understand when we're using a software that we fully understand what it's doing. We should do our own checks also to see that what numbers it is giving, they are correct or not. So all these kind of things should be taken care of. Okay. So how joints are very important. Many times you're not paying complete attention to that. Okay. So joints are important, all these kind of things, the drawings, how we make it. So our students, who are going into design, we have to teach them how to make drawings also. Not only make drawings but read drawings. What kind of notations are there. As I said, drawings have to be very clear. There should be no ambiguity, no confusion. Okay. So that the correct thing is executed on the site. Okay. So all these kind of things are very important. Okay. When you're doing a design, you must know all these kind of things. The fire protection, operation, maintenance, cost, installation of ventilation, heating plants, where will these happen? Because again, these are another type of loads and everything, if it is going to have a lot of vibration or something. So we must know what is all these kind of things. Okay. So of course, usual problems in structures, leakage, corrosion, excessive sag, peeling of plaster, differential settlement happens, sometimes excessive damage during an event or partial or complete collapse during construction. So these are the usual problems in structure. And of course, we should try that with the proper LCA, we should be able to understand that this will come. And beforehand, we should be able to put a solution to that so that it doesn't happen. Okay. So even the owner this time these days is very smart. The owner wants to know that what guaranteed performance of the building can they expect, how much damage will take place, where it will take place, and if it happens, what will be the downtime, so that the building will be closed. They won't be able to earn what they're earning from the building use. What will be the cost of this kind of thing? So there is more accountability, more efficiency, and more specific the engineer has to be these days. Okay, so we should be able to answer all these questions. And there are so many tools of course that are coming, the advances which are there, like design philosophies, they are advancing, codes, analysis methods, structural systems, the softwares, the materials technologies, even concrete, as I said, aesthetics, infrastructure planning, construction methods, everything is advancing, so that these things are becoming better and better. And of course, in another 2-3 years, India will be the fourth largest infrastructure project market in the world. So there is so much coming up. We hear so many projects these days. So we have to have our technical workforce. It should know the latest technologies. Our students, who are going to go to the industry in another 1 year, 2 year. So they should be equipped with good knowledge and the good kind of basics so that they are able to grasp everything and perform. Okay. So we are talking of fast track techniques in building and infrastructure projects. Okay, so definitely we cannot go by old methods now. These days, everything is fast track. Things have to be done fast in the minimum time. Okay, just to start, this is now I think the latest trend. We all must have heard about it. 3D printing. So this is basically an additive manufacturing technique. Okay, So it is very a new building innovation. It is becoming more common in structural design and construction. Okay. So basically, what we're talking here is on-site machines. They can print entire structures from scratch, so which streamlines the construction process and significantly reduce the labor required. Okay. So even it has been shown to be very useful in places where it is impossible to manufacture some specific components otherwise. So 3D printing has been able to do that. So one example is in London, wherein they use 3D printing to fabricate a complex structural steel component. Okay, so in that way, they also achieved the waste and material cost was also reduced. Okay, there are examples in India also. This is one. L&T has already demonstrated this 3D printing in Kanchipuram facility. Okay, so they have a special in-house developed concrete mix, which is available at a regular construction, available from regular construction materials. So the building was printed with both vertical reinforcement bars and horizontal distribution. They use welded mesh, okay, as per the Indian codes, optimize the cost of construction also. Okay, so except the horizontal slab members, the entire building was 3D printed, cast in situ at the job site in open to sky environment, and they used 106 printing hours, and a fully automated 3D printer was used. So these kind of technologies are now coming up, and this is something we should all know. Okay. Now, we're talking of so many impact damages and all those disasters and everything. So even researchers are coming up with such kind of materials, so that in case there is a collision damage, high impact forces come, even to the tune of 60 kilometers per hour. Okay, so they're trying to build this kind of material which is inspired from running shoes and memory foam pillows. Okay, so again, this is a 3D printed geometric shape that they're coming up of a bioplastic. Okay, so that will be taking up the impact. So these kind of materials are now coming up, and as engineers, structural engineers, we have to start using them in the materials. Okay, so from design philosophies, the old ones, working stress, ultimate limit state, so many things are happened, and now we are going to now prescriptive criteria. That how much damage will happen, where will it happen. So not what the world is now talking of is the performance-based design, which is actually talking of the satisfactory levels. Okay, so that is the performance-based design. Okay, which is basically not a prescriptive approach. It focuses on the assessment of consequences of an extreme event. Okay, so there are various stages which are defined in terms of performance indices. So definitely, this is something which is will be coming up very soon in India also. Now, Europe and all, they have already adopted it long time back. What we hear is the new IS 456, which will be coming up. That will be based now on performance based design. So we can, of course, start looking into this also. This will be the new. Uh, this is what India will be using soon as well. Okay. Uh, okay. So, of course, as I said, I won't go into a lot of details. There are many performance indexes which are there. Okay. So, basically, you select a performance objective, develop a preliminary design, see what is the performance capability. Does it meet the objective? If yes, okay. If no, then design it, redesign it. Okay. So, of course, Euro, New Zealand, ACI, American code, they're already using this. Okay. So, this is how it looks. That's the performance curve that is used, deflection load curve, the pushover analysis which is done. Okay, so whether the damage happens, the building will be in a state of immediate occupancy or life safety or collapse prevention. Okay, so accordingly, we say that how much it will behave, how much damage will happen. Okay, so these are some of the things. I won't go into details. Please have a look at them if you are interested into this topic. Okay, so these are the various levels, structural performance levels which are defined. Okay, so pushover analysis is what comes handy here. So definitely most of the softwares which are available, they are offering this pushover analysis, ETAB, STAD, any software you name, they are offering this. So we need to get conversant with this also. So more emerging trends like slab analysis, arching action. Okay, so these kind of innovations are also coming up. Yield line analysis. Okay, so wherein slabs fail with different patterns of fractured lines forming segments. So fracture analysis is coming up these days. People are using FEM in terms of in many ways these days. Fracture FEM and all these kind of XFEM, extended FEM. So wherein they are making assumptions of the crack and everything. So all these things are there, so yield line analysis has also picked up a lot now. Okay, so many softwares are there. Okay, but again, we have to understand that softwares are there to help us, but not to replace us. So an engineer's judgment, the engineers, structural engineers, judgment of what is correct, what is not correct, has to be always there. We cannot just blindly rely on the softwares. Okay, so we must be able to understand that. Now, another trend, which is the most, I would say, the most sought after trend these days, is the BIM. It is the building information modeling. Okay, so basically, it is called a 4D thing. So from 3D, we all know 4D, they are adding a time element. So basically, it is called an integrated digital format platform also. Okay, so most of the companies, they are using it now. The idea is that there are files which are related to the building when it is being planned, it is being designed during construction. So these files, they can be exchanged on network within the with the various I would say the various fields that are involved, as we looked at electrical, mechanical, all those things, civil engineer, contractor structure. So they can share the files on real time basis. They are made like layers in AutoCAD, so decision can be done very nicely. So this is actually now the standard of the industry. There are many courses which are coming up now. People are doing diploma courses in this postgraduate. So this is the demand of the industry now. So if you are conversant with BIM, definitely industry has a place for you. Okay, so we are basically creating 3D content here, but we have to understand that the content should be of quality 3D, that it can be robustly used for construction. Okay, so definitely design teams, they have to hand over the electronic BIM information significantly. Okay, so definitely if I'm trying to make a BIM file which is a general information file versus one which is to be used for design later, with model geometry, metadata and everything, so the kind of details would be different. So I have to keep in mind what kind of data I am supposed to include in that. Okay, so primary building components in design phase, they don't have integration of secondary members, no detailed modeling is there. So I have to understand what kind of file I'm creating at what time. So BIM has to be used very intelligently so that it can give its full purposes. Okay, so many times BIM program, we have to also understand that what BIM design engineer is using. Sometimes some contractors or fabricators, they you are using a different program, so then they take your data into their program, so there might be some ambiguities, they might not jive into each other. So these kind of issues also have to be looked into. Okay, so as I say, what these days this AEC companies, how they are tackling this gap is by taking steps necessary to create advanced model-based deliverables. Okay, so see, Revit is one example of BIM, which is a software which is very widely used in India. Also, even many of our ME students also, they're doing a lot of work on Revit now. Okay, so basically we have to have precision in the modeling and everything so that all the teams can rely on it. Okay, primary, secondary, complex geometry, so this kind of program has to be done. So to have this, basically what now AEC companies, they are doing is they are going for more advanced model based deliverables. Okay, so even the model itself is delivered to the contractor so that he can look into all kind of details. So what you see in the picture here is the kind of detail that is being generated in BIM, and that is being shared further on by the design team to the contractor. Okay, so this kind of detailed work is being done in BIM now. Okay, so even many times now what is expected is even that a structural engineer, one who has designed the structure, the person should directly work with the fabrication person also. There are programs like Tekla for fabrication level, so that there is no disparity in data, and the data is correctly transferred to the fabrication team and the design is properly executed. So as a structural engineer, then you'll have to constantly be in touch with the fabrication team also to solve their queries and everything. Okay, so another important, okay, of course, when we're doing virtually model based deliverables, when we're doing coordination with the contractor. Okay, so if we already have coordinated with them, then definitely fewer changes will happen in the field. we all understand, people who have worked on big projects, there are RFIs, request for information. Once you have done the design, you give the drawing to the contractor. Now when contractor starts executing it, so something might happen, say the pile batter was, instead of 1 in 20, they said today we made the 1 in 19. Is it okay? Can we go ahead? Then as a structural engineer, you're supposed to quickly understand, make your calculations and see if, okay, this will be okay or not. So RFIs come, so apart from that, they may have a question, okay, this bar aise nahi hai, how should it go? What should be the sizing and everything? So if already you have coordinated with them with this model based deliverables, so fewer changes will happen in the field also, then better control of structure quantities also, so our aim is minimum quantities to use for the material, okay, and then they will be reduced or even zero change in orders also for the material that you're ordering and everything. So definitely there is good things to achieve here, so many companies which are big AC companies, they are making their own integrated digital platforms also. Okay, so they're using many tools, processes, and people. Okay, so data flow, information, knowledge across delivery systems. Okay, so all this is happening simultaneously at a very seamless level. So what you see, one example is one of the company which has done its own, made its own digital platform for a facade assembly. Okay, so many companies now they are doing that. So basically, the idea is, as structural engineer, we have to be conversant with all these kind of things. Should be able to understand these things. Okay. Another trend that is now picking up is visual programming and parametric modeling. Okay, so visual programming, basically, let's understand what it is. When I'm doing an individual design program, okay, so that scope is quite narrow. Okay, there is little or no connectivity to hundred of other design processes that take place on every project. Okay, so what happens is, then engineer design beams in one program, then manually transfer information to drawings or to BIM. Then they use spreadsheets to design footings, pile caps, dozen of other structural elements, and that critical data is then transferred from one place to the other. Okay, so now what savvy engineering firms, AEC firms, what they are doing is they are developing their own in-house programming capabilities so that they can customize or mold the commercially available software and create their own programs to do what they need to do. If a company knows that they are regularly doing these kind of projects, so this is their way of doing it. This is how their team is, is has been structurally organized. So even softwares, they are making their all in-house or the commercially available softwares. They are changing to meet their own needs. Okay. So there are platforms such as Grasshopper. This is one name which I found. So this is a visual programming interface. So programming a logic which is very easy to understand and implement. So basically, what engineers do, they write simple programs that connect the very disparate, which are very isolated processes, and improve the speed and the efficiency of the design process. So visual programming is also coming up these days now. Okay. Now, parametric modeling, basically the idea is that I'm trying to establish what are the parameters of a design which can be varied. Okay. Then I set a criteria how these parameters can vary. Okay. Then I can do multiple analysis to obtain the final design of the system over the entire range of the parameter steps. Okay, so this can very help me very quickly say, I can use this process to vary the depth and spacing of steel trusses for an airport terminal. Okay, so that steel tonnage is minimized. So this kind of parametric modeling can be easily used. Or a client quickly comes to you that, okay, I'm trying to do this. Okay, is this option good or not? So if you already have a parameter set and this kind of visual programming has been set up, so you just vary those parameters and you'll quickly come up with a solution, and quickly you can share it with your clients also. Okay, so these kind of preset models also help a lot. Okay. Now, another thing which is happening now is integration of multiple services with the core structure engineering, which I've been talking of from the start of this lecture. Okay, so definitely there is specialization which is happening in AEC. As I told you, people are now coming up with AEC firms. Okay, not isolated structural engineer or isolated contractor. So, of course, individual consultants, they have their own deep expertise. Okay, so even architects and engineers, they are pushing their boundaries of design. As we've seen, so many aspects are getting added. Okay, so of course, but also boundaries have hardened between the disciplines. So of course, structural engineering, they're going beyond structural now of their core delivery, and they're providing a more integrated design. So they have added robust enclosure design services, optioneering of materials and systems. They give options which material you want to choose, design of cladding members, modeling of core cladding components. So that is a more robust delivery of the entire building core and shell and allows for greater coordination. Okay. So many firms, they are now going for this kind of thing. So these are some examples which I found. All these football stadiums and all. So these are showing a lot of structural engineering experiences that are so now structural engineers, they are also adding to the scope the things like erection engineering, especially for complex structures. As I said, it is important to understand how it will be erected, design. Then a high fidelity modeling of rebars in concrete structures. Then threat, risk assessment, mitigation, okay, extreme loading, protection from blast, progressive collapse. All these things are coming as a holistic design solutions. Okay. Now another trend which is coming up is a single model for design. Okay. Now what was traditionally done was designs were developed, documents were created and given to the contractors. Then they would recreate or make changes in the designs with different information. So now this is being changed. Okay. So the idea is have collaboration between the design and contractor so that a single model is developed which can be used by both the parties. Okay. So with this, people are also saving time and money also. Okay. So this has been also demonstrated wherein a 30-month project, जो traditionally 30 months लगते, they have completed in 2 years only. Okay. Even as I said, people are updating the softwares also. People are going for now real-time tracking, resource management, enhancement in project management. Okay. So structural engineers are also part of it. People are going for cloud-powered solutions. Cloud, we are talking of data sciences these days. So all these things, they are being used. Okay. So one example has been demonstrated recently. Okay, so what they did was the information is scanned by the laser within a short time and then it is stored safely on the cloud where it is accessible to the design members. Okay, so any information of the site or anything that is required, so laser is scanning and putting it on the cloud and real time it is available to the designer. You don't have to wait for someone else, कि आप हमें करके दो, they will take time and then they will relay the information. So real time data is coming up on cloud. Okay. Another trend which is picking up is the digital engineering simulation. Okay, so what this enables is that simulation and generation of new designs, more effective, ambitious prototyping of new structures. Okay, so this is one example which was recently demonstrated in China for a hotel building. Okay, so the hotel's intricate structure was possible. They made a very intricate structure for the hotel because the engineers behind the design, they were able to stimulate the structural integrity of a new building that would be constructed on existing abundant foundations. So they were using abundant foundations which were already existing, but they were able to stimulate that when a new structure will come up on this abundant existing foundation, how it will have integrity. So that's how they were able to come up with a design wherein they could work on every single intricate detail also, and they made a very aesthetically innovative structure. Okay, so that's how these kind of things are now also coming up. Simulations, design engineering simulations, they are also becoming very important these days. Okay, I've already told about aesthetics, I will not go into that. Okay, so coming to RCC, as I said, concrete has its own challenges, design requirements. Concreting on site is an example challenge. Of course, one of the most widely used material. So people are going these days for ready mix concretes also. So many advances have happened in concrete technology in terms of the materials which go. Recycle and waste materials are being used now. Mixture proportioning, mechanical properties, durability, concrete test, construction control, all these kind of things, advances have happened. Okay. So admixtures, air rate training mixtures, people are trying to reduce the water requirements since water scarcity is there. Self-compacting concrete people are going for so that there is less honeycombing, less defects in the construction, shrinkage reducing admixtures. All these kind of GGBC people are using alternate materials, waste materials, geopolymer concrete we are hearing, wherein no cement is being used. It is all polymer chains. Since cement, they say manufacturing has a lot of carbon footprint in it. Okay, so natural aggregates, people are trying to replace those with recycled RCAs. They are becoming very common, recycled coarse aggregates. So all these kind of things, fly ash, all these things, silica fume, they are coming into place now. Okay, I think I'll quickly go through these. So even tests and all, they are coming up, new ones they are coming up, which people are using. Okay. So construction control better is happening. So there are advancements in concrete also. Okay. People are talking of high performance concrete these days, wherein for a given particular performance characteristic, special concrete is developed. Like, say, you want to have some placement and compaction without segregation, so you specially develop a concrete for that. That is high performance concrete, or an early age strength, or enhanced mechanical properties, freezing, thawing. Something that you require high resistance. So these are high performance concretes which you can develop for a specific requirement. Okay. So these are some of the things which can be there, and there is a lot of application. I think we're all hearing about it now these days. Instead of high performance concrete, people are even gone to ultra high performance concrete. So any superior ductility, energy absorption, less steel, corrosion resistance, all these things come up into play for the characteristics. Okay, so these are so many types of construction materials which are already there, which are being used. I had simply gone to Wikipedia and I could find so many names. So I was actually very astonished when I saw that there are so many types of, varieties of concrete that have come up, recently. Okay, so just have a look at them. So as engineer, we should know how to where to use these, when to use this, and what is the availability. Accordingly, we can use them in our structures. Okay. So many companies, they are trying to say that instead of cement adding to carbon dioxide, we are trying to make cement which is environmental friendly completely. People are talking of smart concrete these days. Okay, just like a smartphones, they can sense everything. Concrete can sense, so they are putting a lot of sensors in the concrete now, which is also good for the rehabilitation and everything. Smog eating concrete, which is using titanium oxide, so that is the photocatalytic reaction. This is one example where it has been used somewhere in Canada, I think. Then RPC, another very high, ultra high strength, high ductility reactive powder concrete. The idea is to use very fine particles and less of coarse aggregates. Okay, so these kind of things, translucent concrete, light transmitting concrete. So they have optical fibers which are put into it. Okay, so there are many options. Self-compacting concrete, as I said, not vibrations required. Lightweight aggregates are being used. Okay, so that is also good. So that natural material is used less. Okay, and most of these, so performance wise, the research which is already available, so we can make a choice of which one can be good for our case. Okay, decorative concrete, stamped concrete, these kind of options are also coming up. Then a different type of carbon fiber reinforcement, carbon fiber post tensioning, gels to replace water. These kind of things are coming. Government, 2 years back, they already gave this notification that alternative materials and technology should be used in highways. So all these things, if you see, they have listed out. So of course, the idea now, as I said, is to use alternate materials so that cost can be brought down and also minimum harm to the environment. Okay. Now coming to the next technology, if you all can identify from this picture, what we're talking of is the modular construction. This is also now a recent trend, which is coming up a lot. Okay, so that is innovative, of course. Old also it used to be there, but now it is becoming more and more popular. More innovations are coming out. The idea is when we have to construct buildings, design and construct them quickly without sacrificing their integrity and safety. Okay, so especially commercial units, buildings where box units are either stacked or set side by side, this construction becomes very helpful, and there is a lot of focus to go into these kind of things, especially residential mass housing when we are doing affordable housing. And in fact, I would encourage all of you to also, look into as, project which is the lighthouse projects, wherein for affordable housing, six technologies have been chosen and they are being demonstrated in six cities, wherein in a period of 1 year they'll be producing many thousands. Government is trying to demonstrate how in a period of 1 year many thousands of houses can be constructed. So they're using very technologies like precast construction and all, steel and everything, lighthouse, the hollow sections and all these kind of constructions are being demonstrated. So please go to the website. You can put LHP, lighthouse projects. You'll be able to come up with all the, and they are constantly posting what is the development happening. Okay. So this precast, it can be used in many applications, as we can see. Okay. Open truss, hybrid construction, concrete, insulated concrete form walls. Okay. So this is an emerging trend, of course, but when we're going for precast, there has to be some considerations for a design engineer, and definitely the joints are very important here, because that is what are ultimately joined on the side. So design of joints are very important. Okay. So knowledge for structural engineer is for progressive collapse, diaphragm action in floors, joints connections, detailed structural systems, constraints and consideration in precast manufacturing, recastability, all these kind of things should be known to the structural designer. Okay. So they are very popular these days. They are being used for all these applications, as you can see. I've already written them for bridges, all elements they are using. In building and garages, they are using it for storage, for drainage and water treatment. Various applications are there. Highways applications are there. Landscaping, they are using it. All these are precast elements. Then noise control, okay, even in soil retention, underground utilities. Okay. Now, apart from other than that, even form work is getting better. There are more applications for form work. People are going for LBW systems, fast track 24 hours, which can be reused. So form work has become better now. Tilt up industries reaching new heights, almost 100 feet they have done with load bearing walls. Okay. So that is the tilt up technology. Please look into this also. So these kind of things are coming up. Reinforcement, as I said, people are going for fibers also now. Reinforcement carpets are coming up. Okay. So corrosion issues are there. So these proves to be very good. So as we can see, reinforcements apart from steel, now galvanized, ECR, Z-bar, epoxy, FRP, they are also becoming very popular. Okay. So even in FRP, fibers can be glass, carbon, aramid, basalt, even natural fibers are also used. Okay. So they have their own. Okay. So some innovative technologies people are also coming up. This is one technology which was demonstrated in Canada in one of the university, Toronto, I think. So basically, what they have used is the biaxial carrying hollow slab, in which there are plastic balls which serve the purpose of eliminating the concrete, which is kind of a dead load. They have gotten rid of that. So it behaves like a solid slab only. It has a true biaxial behavior, which is uniform in any arbitrary direction if you talk of. Okay. And forces are very easily distributed because of this plastic balls. So yes, Toronto, this university, they have demonstrated this. Okay. So because of reduction in mass tab also, so these are kind of technologies which a structural engineer needs to see. Now, another good technology I would definitely like to mention is integral bridges. I think we are all starting to see this also in India also. So what we see here is beautiful bridges. The idea is the pain part, which is there always, the connect between the superstructure and substructure, which is the bearings, for which maintenance is an issue. So those have been completely done away with. So we don't see any bearings here. Superstructure, substructure, there are no bearings here. So these kind of bridges are also an innovation. They look sleek, nice. We are saving material. We can go long spans. Okay, they are very pleasing also. Okay. Next trend, of course, another very important trend. What you see here is construction 4.0. Wherein I'm talking of everything is automated. So if a construction site, everything is automated, of course, the design has to be done in that way. And here is where, as I said, modular precast construction is the way to go. So as you see, the first part here is prefabrication and modular construction only. advanced building materials, autonomous construction, 3D printing, big data, all these kind of things. Now we are talking of construction 4.0, wherein everything is connected via internet, via Wi-Fi. So everything is being monitored on a single platform, and we can save a lot of cost and money. So design is also important part of it. Okay. So IoT is now in construction also, and this is one aspect where we all have to start learning. Okay. Since I know the trend now is for tall buildings, so especially recently India had also released in 2017 a code, IS 16700, which is for the structural performance of tall buildings. So these are definitely the trend, the tall buildings. So there are a lot of things to look here also. So for structural engineer, if I see, so where its height is affected by the lateral forces such as wind or earthquake. So I have this secondary P delta effects coming up. So tall buildings have already been there, and more are coming up now. The India also trend is rising. So I have to be very, there are different aspects apart from a regular building which has to be seen in this: strength, stability, design criteria. Human comfort is very important here, because we are talking of high rise. People are, very high in altitude, so they have to be having that comfort level also. Okay, drift limits have to be kept. So these kind of structural systems which are there, which are popularly used. So as structural engineer, we should have knowledge of these kind of things. Okay. Of course, issues are there. People have to work on heights, the workers and everything, accidental loads, all these kind of things. So we have to be very careful. How do we do that? Vibration controls. So people are putting a lot of things for that. So as structural engineer, this is a knowledge, the things we have to put. Facade design, how it should be done. Then there is something called as an interference effect. So wherein wind tunnel CFD studies can help, because there are tall buildings side by side. So when a high wind is blowing, so there is some interference which happens, which is what we are seeing here now. This is all because of tall buildings. So this kind of discomfort also has to be looked into. Okay, pedestrian comfort and everything, geometric conversation. Of course, we go for streamlined designs and everything. Okay. So that's how these buildings are made. So there are special, of course, analysis which are done. Then air pollution has more effect at the top stories. So these things have to be looked into. Okay. So which brings us to, of course, the topic which I'd already already introduced to you: sustainable infrastructure development. So we have to go with the environment now. Okay. So this should include not only sustainability in terms of materials, environment, but social inclusion should be there. Infrastructure that includes all society. Citywide expansion should be consistent with urban growth. A problem which we are facing now, every year now, cities like Bengaluru, Chennai, and I would say this time I stay Chandigarh and around. Even I could feel that with the rains, how the city was flooded, which just showed how like the drainage was not properly planned. The cities are just coming in haphazard manner. So the natural drains, we are all choking that. We are all blocking the natural drains of the water. So we have to be understand how infrastructure develops. So as a structural engineer, also we have to keep these things in mind when planning happens. We should be a part of it. So all these kind of things have to be there. Okay. So of course, resources are less, but more people to feed. So there are many technologies which are there. So these are the five main: minimize material use, minimize material production energy, minimize embodied carbon or energy, life cycle analysis. Try to have maximum structural system reuse. Even after the building has surpassed its design time and all. So if the structural system can be reused for the next building, so just try to use that. So less and less material should be wasted. Okay. So of course there is no single methodology, but there are many ways to do it, and there's also a dedicated session in the afternoon for the sustainable structural engineering practices only. Okay. So structural engineer, now we are supposed to know that which material has what is the embodied carbon in it, what is embodied energy in it, its life cycle analysis that has to be known. Okay. So for designers, you should understand what is embodied carbon, how where it originates, how building impact the amount of carbon in the environment, and if there is excessive carbon, what will be the consequences. Then we have to accurately know and robustly track the quantities of the structural elements. Okay. Then we have to develop workflows as designers that allow us to analyze and understand the effects of material choices. Okay. Then, with this information throughout the design process, I have to go for options that keep evaluating the carbon impact and other important design factors so that I have minimum embodied carbon for my particular building. Okay. So even structural engineers, what this SC 2050 is, basically the structural engineers around the world, they have formed this kind of, an understanding, just like we have Montreal Protocol, Kyoto Protocol. So they have made this group wherein they are trying to say that the structural engineering community, fraternity, the type of new buildings that will come up now, they will have reduced carbon emissions. Okay. So try to use salvage recycled material, zero waste practices, as I already discussed with this beam and digital platform, single model and everything. So there will be zero waste if already with contractor, the designer is already in touch with him. They're coordinating, they're using the same model, same file. So proper things will happen. And of course, the buildings, the material that we use, the way the building materials we are using, the facades and everything, so there should be energy efficiency also. We should maximum try to see what kind of climate our building is in, so that there is minimum use of energy, artificial energy. Okay. So of course, concrete pivot. Coming to design codes, let's just take a 2 minutes quick break. I'll just be back in 2 minutes. Just one. Okay. Oh, what did I do? Okay, yes. Now coming to the next part, as we discussed about design codes, how they are very important for any structural design. So, of course, these design codes, like national building codes, they are formulated in different countries so that there are guidelines how the structure should be designed and constructed. So, of course, it is evolving from collective wisdom of expert structural engineers, which is gained over many years. Okay, and periodically there are revisions also. So, of course, the idea is the code should be flexible also, and at the same time, they should address the emerging techniques, materials, and sustainability issues also. Okay, so when I'm talking of trends, the design and analysis. Okay, so there has been a lot of development which has happened in last 80 years. Okay, so a lot of code strength formulations have become more detailed, more research findings are being now incorporated into code. Second order advanced analysis are coming up as a major requirement now. Okay, people are now going for design optimization, especially mathematical optimization, wherein a real function we're trying to do maximization or minimization by having a systematic choice of input variables, and computing the value of the functions. Okay, so for, as I said, for this optimization, in design also they are doing it, and that's where artificial intelligence has started playing a very big role. Okay, so these optimization algorithms, they are picked by many nature inspired processes around us, and gradient methods like genetic algorithms, the way Charles Darwin's theory works, survival of the fittest. So how, you put in two variables, whichever fits the given criteria, those are used for a new variable, and that's how it goes on. Then evolution strategy, ant colony, how ants they build their colony, so that kind of things. Particle swarm, so swarms when they go, how they are following a pattern with which they are moving and everything. Neural networks, artificial neural networks, like the way our body is sending signals through neurons, through nerves throughout the body. So hill climbing, taboo search, and all these kind of, these are optimization algorithms which are being used very widely now for structural design also for optimization. Okay, so these are all recent trends which we all must be aware of and try to use them. Another trend is design against progressive collapse. So basically the idea is that when we're talking of robustness, so that the structure is able to withstand events like fire, explosion, impact, consequences of human errors without damage, that there is no disproportionate. Okay, so this basically the idea of robustness or design against progressive collapse, the idea goes back to 1968, wherein one bearing wall failed, and that led to collapse of part of the building and loss of life. Okay, and also the World Trade Center that happened in 2001, the incident. Okay, so after that, this progressive collapse design has become very important, so that there is adequate resistance to various damage scenarios. So this is getting a lot of importance these days. Okay, another very important trend which is coming up now is the self-healing materials. Okay, so basically now people in the design in the buildings, they're using materials which are self-healing. So the idea is basically what we're talking here is of materials, which can self-heal themselves. People are even using, smart alloys also, like bacterial concrete is coming up, wherein if a crack happens, the bacterial concrete is made from that kind of material. It's able to heal, fill up the cracks. Some people are putting resins in the tubes. If a crack happens, that tube breaks up like a fuse and fills up the crack. Okay, so all these conventional materials, they are being upgraded by these additional things. Okay, so these kind of interdisciplinary science, biology things are also coming up, and basically new types of materials are being used, such as these also. Okay, yeah, so as I said, smart concrete I've already shown you. So there are other smart materials also, like smart material alloys, SMEs. Okay, so they are also picking up a lot. So basically, in case there is any change in the material property, geometry, mechanical or electromagnetic response, okay, so the material is able to sense it. Okay, so both sensor actuator functions, they are there, they give the feedback, they have to be integrated, and which is playing a very big role in structural health monitoring these days. So sensors are being embedded within the structures to monitor the stress, the damages. So this can reduce the maintenance cost, it can increase the lifespan. Okay, so it has been used worldwide now. Okay, as I said, sustainable structures are required. Okay, so renewable energy sector. Okay, so buildings, they need to now start into integrating the renewable energy options. Your building should be able to do that. Like there are examples wherein very high-rise buildings, which are going, very very high, up to 80 meters or something. The structural design incorporates wind mills, all these kind of things, so that at height the wind is there, that can be utilized. So as structural engineer, we have to start thinking of those things, that how we can generate a renewable energy with our structures, and also how we can incorporate renewable energy for our structures also, and use it and generate it also. Okay. uh, Even with steel, there are a lot of things which are happening. Structural steel, many new grades have come up which are lightweight, cheaper, high strength. Okay. So 2020, in the year they were supposed to come, and actually many have come. Okay, and even the carbon dioxide breakthrough, so there is a lot of programs, so that from the steel manufacturing itself, carbon dioxide emissions can be reduced. So they are looking into the life cycle approach that I've already discussed with you. Okay, so reuse, recycling at every point of product's life cycle, right from raw material extraction to recycling and end products. Okay. Another trend which is picking up, as I said, we just looked into one example wherein a design firm was using cloud for real-time data from the site. Even drones are being used. So, drone mapping services, it can provide a very accurate view of a site as it exists. Okay. So during earthworks, during building foundations, real-time pictures, real-time data can come. Structural inspections, the drones can be very helpful, where humans cannot reach at inaccessible places. Drones can be sent. Okay. So even workers, they can be saved from the from the risks, things which are more risky. Okay, so drones can be sent there. Okay. Even new safety tech is coming up, wearable safety devices and all these kind of things. RFIDs are being used to detect people in the path of a machine. Virtual reality power training programs, they are being used. Okay, so fences, covers, body harnesses, all these kind of things, they are now coming up for the uh, as safety technologies. Okay. So there have been various revisions in the design standards also, which I just wanted to discuss a little. So this is just one thing, how engineered is, actually, as living things, we are influenced by various factors which are around us: international, political, economic, education, technology. So definitely, there are been so many changes. Nature of occupancy, high rises are coming, mixed occupancies are becoming more fashion these days. People are talking of sohos, shop come houses and all those kind of things. So, nature of building services, there is a lot of dependence. New innovative construction materials, technologies, preservation of environment is becoming very, very important. There is need for planned management of existing building and environment. So, a lot of things have come up. So, just showing you this, I'm sure all of you must have read about it. So, this project is going quite good. So, this is the world's highest railway bridge, which is on the Chenab river. So this is an arch bridge that is being constructed by railways. Okay, so basically the idea is, it is quite a very ambitious project, and what they have designed is the height above the river is 35 meters more than the height of the Eiffel Tower. Okay, so it is 1315-meter long bridge, 17 spans, main arch is 467 meters, and it is 359 meters above the Chenab River. Okay, so will be a 14-meter dual carriageway also, 1.2 meter wide central verge, and it will allow a design speed of almost 100 kilometers per hour, and the lifespan has been made for 120 years. And can withstand speeds of wind up to 266 kilometers per hour, and temperatures of almost minus 20 degrees Celsius, and earthquakes up to 8 magnitudes, and high intensity blast. So this is the kind of structure which has been designed, which is coming up, and its construction is in full sway. So all these things, they have used BIM software, they have used Tekla. I've already mentioned these things to you. Tekla was for fabrication. Okay, so all these kind of things. So we can see is how these things are coming up in India also. Very good projects. Okay, yeah. So this is the latest picture of this only. What is coming up? It is coming up. Okay, this was, I think, a month or two back. This picture was taken, which I have included now. The same Chenab Bridge. Okay, then other 8-lane longest extra DOS bridges are also, people who are actually into bridge engineering, they would appreciate that. Extra DOS bridges are actually, structurally very superior performing, a lot of material saving, lot of space saving. Okay, so this there is one which is coming up for 2.2 kilometer long over Narmada River. Okay, so people who are interested in structural engineering, they can follow these kind of trends. Okay, so for the code also, new formwork techniques, faster construction materials have been included, proof checking, peer review. Okay, so all these things, they are being introduced in India now. Okay, so recently all these codes have changed. I'm sure everyone must be conversant with it by now. Okay, so at this, as I had already mentioned, 16700. This was the new code which has been introduced, criteria for structural safety of tall buildings. Okay, so NBC, the new thing which has happened, already actually, if we see our NBC, many times structural engineers, we are not referring to NBC. So it is a very useful document which must be looked into as well. So already NBC, if you see the way they have given the guidelines, they talk of sustainability only. But this, in the 2016 version, it has been included more exclusively also. So if you're following NBC and all, so your buildings will be sustainable, which is the new actually requirement. Okay. So basically, they are going for structural safety certification that has been made very mandatory. So that's quite something that structural engineers, it's an important thing. Okay, so from a competent professional, they say you have to ensure the structural safety of the building, peer review of design, accessibility for person with disability and elderly. So your design should include all these aspects, provision on fire, life safety. Okay, so all these things are being now made mandatory in NBC. Okay, latest structure loading, design, construction, all plumbings and everything, new alternative materials, they are stressing on that. Construction management guidelines, they are talking of structured use of glass, escalators, moving walks, solid waste management, asset and facility management. They're talking of all these kind of things. Okay. So just listing a few as per new 13920, minimum dimension of column, they have said 20 times diameter or 300 mm. So we should know all these kind of things when we are picking up. So not, I don't want to go into a lot of details, but these were the major changes that had happened. So minimum column width has changed for the beams, 20 bars, 400 mm, 25, 500 you have to go. So these are all structural ductile detailing requirements. If you are going bent up bars, implied links, concrete and RC section, so you have to do shear force also, you have to look into that. So all these things are new and which have to be incorporated. So of course they've been here for now 4 5 years, but still many times we see that the awareness is not there for the new code. So our children, they should be actually given knowledge for these only. Okay, IS 1893, how to calculate the earthquake loads, that has changed. Okay, so as far as possible, the structures should be able to respond without structural damage to shocks of moderate intensities and without total collapse to shocks of heavy intensity. That is what is required. We don't say that the structure will not even have a single crack if an earthquake happens. We don't want to unnecessarily overestimate and make our structures very, very, I would say, the lot of factor of safety we don't want to put unnecessary, which will make it very uneconomical. We don't know the earthquakes probabilities are less. Okay, so of course. Even for tall buildings, they are coming up with a new code, one more. Okay, base isolation, energy absorbing devices are being advocated. Okay, detailed experimental data, only then you should go for non-standard devices. Okay, detailed analysis, they are saying you must do the dynamic analysis has been made mandatory for many cases based on the zone and story heights and everything. Okay, Even this importance factors has been revised. Earlier it used to be just 1 and 1.5. Now 1.2 has also been introduced. Okay. Even for irregular buildings, they have actually spelled out lot of irregularities, like vertical irregularities because of lateral stiffness, soft stories, mass, vertical geometry, in-plane discontinuity, discontinuity in capacity, like weak story. Okay, so plan irregularities like torsion, re-entrant corners, all these out of plane. There are very explicit diagrams which now, so they are very explicitly now addressing all these issues, how they have to be considered for a design. Okay, so tall buildings, the code 1670, that is for height greater than 45-meter but less than 250 meters. Okay, so more than 250 meters, they are calling that super tall building. Okay, so these are the kind of structural systems that are being advocated. Okay, for this various seismic zones and various heights that you go for. Okay, so plan aspect ratio becomes important here. How much we cannot exceed 5 for that. Slenderness ratio has been limited in this way. Okay. So of course, as I said earlier, it was this, but now it is like everyone is involved with everyone. It's not that this person will not have any interaction with this person. So everyone is involved with everyone, as we have been seeing. So many things are happening. Okay. So of course, with our growing economy, there's so many things coming. There are projects like Gati Shakti, which are coming, which is a national master plan for infrastructure development. Okay, so what they are trying to do is involve a lot of GPS also, 16 ministries, including railways, roadways. So everyone will do an integrated infrastructure development so that it is all coordinated. The kind of problems we are facing now these days with cities flooding and everything, so that will not happen. So 200 plus layers of geospatial data, okay, on existing infrastructure. Okay, so various government departments, they will track in real time. Okay, and at one centralized position, the progress of various projects. So budgets can be prioritized, people can be prioritized. Okay, so this will cut down the logistic costs also. Okay, so the idea is there is a new road constructed by one department, and few days later another department digs that very road to lay water pipelines. So that is nothing but but lack of coordination why this has happened. So that's what's being trying to tackled by this kind of projects. Okay, so that's the master plan they are trying to have. Okay, so with this, I'll put a stop on my presentation.